Okay, so I will start my presentation. So good afternoon, Dr. Wan Amil to uh, good afternoon, Dr. Wan Amil. I'm from Group 6. So my project is Smart RFID Transportation System. So my name is Isaiah Ong Wei Sheng and my teammate is Muhammad Nakib bin Azhari. So this is our contents of our project, which consists of overview, introduction, methodology, experiment setup, results discussion and observations, conclusions, and future works. So now I'll move on to the first part. So for this overview of this project, we use mainly the RFID system because an RFID system can speed up the process of sorting parcels as it can read up to 300 tags per second. So why do we need this? Because we can reduce the manpower, which is effective to prevent the spread of COVID-19 because we can practice the social distancing. So the objective of this project is to combat COVID-19 and quicken the parcel handling process. Okay, so this is our methodology. So this methodology is follows the Mechatronic uh, Design Philosophy. So first we recognize the need of in transportation, then we generate idea of the circuit using Proteus 8 Professional. Then we discuss the most suitable circuit. Then we move on to modifying and constructing the finalized circuit. Then we test the circuit on Arduino Uno. Then if the circuit is working, then we will proceed. If it's not working, we'll troubleshoot and see what we need to modify. Then after the circuit is working, it will show the RFID tag code so we can record it down. Then we continue here. So we record the code down, then we know that we need to register the tag into our system. So we finalize the coding for the RFID sensor to read the RFID tag. Then we test the circuit. So if the circuit is working, then we can finalize our prototype. Then if not, we have to proceed to troubleshooting again. Then if it's okay, we'll move on to our final report and presentation. After that, we'll complete our report and we can submit. So this is a rough idea of our project. So the RFID sensor will detect the UID tag, then it will send into the Arduino Uno. If it is correct, we'll have an LED light, which is a blue LED. So if it's correct, the blue LED light will light up. If it is wrong, the blue LED does not light up. So this is our Proteus 8 Professional set the schematic. Because for Proteus, there's limitation which we cannot use RFID the sensor, so we need external components. So we have to use the hardware setup to show our RFID system. So the black color part here, like all these components here, is actually virtual port, which is not really realistic. So hardware is more practical. So this is a short video for our project. Okay, so in the video, there's one part where we use the correct card. So for if the blue tag, which is the registered ID. So for the registered ID, you can see that the blue light lights up. So if the wrong card or no card was scanned, the yellow light will continue to light up. So this is roughly what we showed. This is called the serial monitor window. So if the correct part, the UID tag, this is the one registered. So if this one was detected, the parcel will output the message parcel detected. So if the one like this one, it's a different UID tag, so it will output the wrong parcel, or the yellow light will continue to light up. So in conclusion, the parcels will be more easily found with shorter time. So less manpower is required for parcel handling, which enables the practice of social distancing. Then searching of parcels without physical touch will also prevent the transmission of COVID-19 because if too many people touch the same parcel that might have the virus contaminated, the virus will get spread very very extremely. So for future works, we will try to use wireless charging so that multiple RFID modules can operate at the same time with only one power supply and also with less cables. Then we can display the UID tag code on the LCD screen to identify whether the correct parcel has been detected. So that's all from our group. Thank you.
Okay, thank you, Asaya. Can we move to second group? Group 21, please.
Good morning, Doctor.
Good morning.
I'm Teswiong from Group 21. My teammate Kunju will be presenting our topic. Our topic is smart vertical. I can see, Doctor. Can you see the slide?
Yes.
Yes, our topic is about smart vertical aquaponic systems. And our objective of this project is to be able to design a circuit and implement the knowledge inside digital and analog circuits to create advanced system which has real-life application. So for us to be able to analyze, troubleshoot and solve the problem during the circuit design, and we are also able to work in a team to promote good engineering values among team members, and also we'll be able to communicate and present ideas in oral and in the formal format, written technical report. We start from the prototype modeling. This is the design that we have come out. You can see we have the fish tank down there, and we have the frame beside, and we have the growing pipe for the plants. We have the gutter to enable the water to go down, and the water hose pump the water up. And then these are some of the pictures for our modeling, preparation of components to cutting materials to shaping the growing pipe to assemble. And this is our final modeling. And you can see we have pipes. Instead of using rubber pipes, we use the PVC pipes to uh, tie on the frame. And we move on to the circuit implementation. So this is our water sensing circuit, which used for auto refill pump system, and also our water leakage detection system. So this is a bit of demonstration of this circuit. So when the water sensor is installed at the desired water level of the tank. So when water when the water sensor detects water, this means that the pump is not activated because the water is at the desired level. When the water sensor does not detect water, the water level is not this indicates the water level is not at the desired level, which will activate the pump to pump water to refill the fish tank, and then after the water is refilled to the desired level, the pump will stop. And this is our circuit for our auto fish feeder, and this is the video for the demonstration. I'm sorry, that's my mom. Now I'm gonna do this. So when we'll be using a motor servo attached to the plastic bottle, and by looping daily, the plastic bottle will rotate and the fish food will drop into the fish tank.
Okay, so this is the light sensor to be used in our aquaponics system. Next, see the video. So here, run, play. So here you can see that when we have light on the LDR, which is the light dependent resistor, the LED won't be lighted up. So like during daytime, we can see that the LED won't be lighted up. But when light is further away from the LDR, we will see that the LED will be lighted up. So that means that even during nighttime, will have enough light for the plant. Next. Then this is the ultrasonic sensor, but this is just a schematic we build using Proteus. So here, this is the ultrasonic sensor that we build. So this ultrasonic sensor will sense anything in here. In this case, I set 50 cm as his range. So it will scan anything within the height, within the vicinity of the ultrasonic sensor. So if anything within 50 cm of the ultrasonic sensor, the LED will be lighted up. But if there's nothing within the 50 cm, then the LED won't be lighted up. So we can see here. Wait for the video. As you can see now, here we have one obstacle here, so the ultrasonic sensor will sense it, then the LED in the circuit will be lighted up. So no matter the object is within 50 cm, so the LED will be lighted up. Then if we remove the object, the LED won't be lighted up again. Next. So we have a few problem faced when doing the project. So due to this COVID-19, we are hard to discuss about the project with teammates due to the availability of direct conversation. So some of the idea that we need to try reach to our teammate is very hard to get. Then because of we use the simulation, so there's a difficulty in finding a library for the extra component that to be added in the software when building the schematic for the circuit. Then we also cannot get some of the sensor to be working in the simulation software. So most of our circuit are built using Arduino.
Such as the pH, we will before this we plan to the pH sensor to measure the pH value of the water to get a maximum efficiency, but we can't seem to get the components in Proteus and also in hardware configuration. Thank you. This is
Thank you.
the end of the presentation.
Okay, thank you, Tesu Yang and Chu and Ju. Next, we proceed to group 17, please.
Hello, doctor. Can you hear me?
Yes.
Okay. Hey, good afternoon, Dr. Wamia and my fellow friends. I'm Ng Chun Po, and my partner is Ng Jijun. We are from Group 17. Today, we are going to do a presentation about our mini project, the Smart Alarm System. Okay, first of all, the main objective for this mini project is to protect people from the COVID-19 pandemic, besides resolving the security problems faced by the community nowadays. How are we going to achieve this objective? Basically, our system consists of two main parts, which are the Arduino Uno and the synchronous counter. Besides that, this system is also equipped with many necessary sensors like the motion sensor, temperature sensor, gas sensor, and so on. This smart system will sense and record the number of people entering or leaving the facility and their body temperature to make sure that the number of visitors currently being in the facility will not exceed the certain number and all of them has a body temperature below 37.5 degrees Celsius to complement with the SOP rules. Okay, now I will pass to my partner to continue presenting the following slides. Jin.
Okay, good afternoon, Doctor. Now I'll take over for Ng Zunbo. So now we're going to talk about the methodology. So in this mini project, we are using the Proteus 8 professional simulation software to obtain our results. For security measures, PIR sensors, temperature sensors, smoke detectors are used. And in addition, there are also a bunch of other components such as the servo motors, LED, jumper wire, breadboard, 7-segment display, the JK flip-flop, AND gates, OR gates, and adder, and also the BCD to 7-segment display encoders. So over here we have our process flow. So first thing what we're gonna do is to start our project. Then we will design our schematic inside the Proteus software. Next, we will select the components that are necessary to use for our mini project. And next will be the wiring connections, and then we will start typing our Arduino coding and upload it to the Arduino file, Arduino Proteus simulation. And then we will start simulating the circuit to observe the actuators animation to see if they're working or not and obtain the result. And lastly, we will do a final conclusion. Okay, next. So this is our entire circuit. So the upper part consists of the Arduino Uno, and they are being cascaded to the digital components. The digital components are actually the counters. I'm very sorry that the circuit is quite large here, so I'll explain more about it during the demo. So so here we have the count at 8-bit counters. There are two 8-bit counters, one for the entrance and one for the exit. So the entrance will keep track. So both of these entrance and exit counters will be cascaded to the 8-bit subtractor. So we cascaded it by connecting the exit counter, the bar Q output to the second binary number of the adder. So they will become first complement. And then we add the first Cin input connected to a high voltage. So that way the exit bit will become a seconds complement, while the entrance will stay the normal binary number. So that way they will calculate the differences and it will be shown onto the 7-segment display. And if there are less than 7 people, the comparator will display the green LED to indicate that more people are allowed to enter the facility. We design this counter in such a way that we assume that in a particular day that a person will not visit the same store for the person 255 people will not exceeded the limit for a particular day when visiting the store. And if the people that are currently inside the facility are 7 people, the red LED will light up to indicate that no more people are allowed to enter the facility. And then when the 2 infrared sensor will also be detected, and it will be sent to the Arduino Uno circuit to open the servo motors. We have 2 servo motors, which are the entrance and exit motor. So before they enter, they need to scan their body temperature. If their body temperature is above 37 degrees Celsius, the red LED, the alarm, and the LCD will be activated. And then the PIR smoke detector here will be the sensors for the intruder and for the fire outbreak situation. Okay, next. Okay, so this is our result from the 2 synchronous up counters and adders. So from FF4B which is the MSB of the entrance counter, and then to the FF1A, which is the LSB of the entrance counter. But we are only interested in the last 4 bits of each of the entrance and exit counters, since they are the ones that we are going to use for limiting the 7 people. So so then when they are cascaded to the adders, the summation output of the adders, which is the S4, S3, S2, S1, it will show the differences of the people entering that are currently in the facility. Okay, and next. This is our result for the comparator. So for the comparator, as we can see here, when there are 6 people still inside the facility, this green LED will still light up. But after one more person enters, which will make the total number 7, the red LED will then light up and the green LED will turn off. So this will want people to not enter the facility anymore. Okay, next. Okay, for our discussion, so when there are more than 7 or more people in the facility, the red LED, which will be the indicator from the comparator, will show an active high output. This is to warn people that that the space has been fully occupied and to complement the SOP rules. And before a person enters the facility, which may be a convenience store or a jewelry store, if the person has a high temperature, an emergency light will be detected, and the LCD screen will display high temperature detected iris, so that they are not allowed to enter the facility. They are warned not to allow to enter the facility. The infrared sensors are used to activate the servo motors when a motion is detected. And when there is a fire outbreak, the following safety protocols will be activated. The first one being that the buzzer will be set off. Then the servo motors will automatically be open to allow the people to escape in time. And then the water sprinkler will also be activated. And the LCD will then, which is the monitor screen, which will then send the following information to the authorities so that they can come in time to put out the fire. And then for our last safety protocol measure, which is when an intruder breaks in during the night, or when there's an intruder detected, the buzzer will set off, and then the servo motors will be shut closed to like prolong the thief from escaping, and then the LCD will be sent to the authorities to try and hurry and apprehend the intruder. So when we construct this circuit, we have we have faced some of the problems. One is that the wiring, as shown just now, when our circuit is quite complex. So if the wiring is wrong, our counter will not count very accurately. And then when we upload the coding, there's a bunch of bugs that we need to fix, and so we have to do a lot of trial and error. We also have to learn to learn some of the coding from the internet, like the LM35 temperature sensor and how to declare the variable and so on. And there's one flaw from our design, which is that if in the event that a particular day that the total number of people that has entered the facility is more than 255 people, then the counter will not be able to function properly anymore, and the technical staff will have to manually reset the circuit by using the reset on the JK flip-flops. Okay, I think that's all from me. I'll now pass my mic to Junpo.
Okay, thank you, Zijin. So, as a conclusion, an Arduino-based smart alarm system is successfully designed and manufactured through the simulation by using the Proteus and Arduino programming IDE software. We have achieved the objective of this mini project by applying the knowledge and concept from digital and analog. The components used by us in this simulation are readily available, their prices are affordable, and also they has high reliability. Despite this project still has some limitation, like the infrared sensor might also sense the other moving objects except human, and this will lead to the miscounting problems and hence affecting the whole system. Thus, the head counting part can be said it is not 100% accurate. By the way, in this mini project, we do not consider this as one of the factors. In the future, we recommend to add on the Raspberry Pi 3 board with a webcam mounted on it so that the smart alarm system are able to process the human detection so that the system will only detect the human but not the other moving objects to solve the problem mentioned above. Besides that, we also may consider the Arduino Mega as our microcontroller so that a more complex objective and some hardcore electronics can be applied into our system. Finally, we also will add more sensors like the photoelectric sensor, microwave sensor, tomography sensor, visual sensor, and so on. That's our presentation for today. Thank you.
Okay, thank you.
Thank you, Doctor.
Chopo and Zijun.
Thank you, Doctor.
Can we proceed to group 13? Ziyuan and Zulhilmi, please.
Doctor, can you see our screen?
Yes, please proceed.
So, very good morning, a very good afternoon to our fellow friends and our lecturer, Dr. Wan Amir Fuad YGT. Today, we're from Group 13. Me and my group member are going to present our system for smart tourism. So, the title of our mini project is Temperature Screening and Crowd Control System. So, this system is divided into two parts. This system is divided into two parts, which is the temperature screening and the crowd control system. Next. Next slide. Okay. So the objective of our mini project is to design a smart tourism system that can combat the COVID-19. And second one is to detect early warning sign of infection. This is related to the temperature screening system as it is proven that body temperature is one of the early warning sign of infection. So we construct and design this system so that we can combat the COVID-19 and in order to reduce close contact between people in the premise. So as an introduction for our mini project, we have two main functions, which is temperature screening and crowd controlling. So generally, the temperature screening system is depending on the crowd controlling system. It will only operate if in a specific condition which depends on the crowd controlling system. And then this mini project is suitable for any building and location with specific entrance and exit. Next, I would like to pass the presentation to my group member Lee Zuyuan.
So good morning, good afternoon, Doctor. So for our methodology parts, mainly we divide into 4 parts. So the first is literature review. So from that, we can know the knowledge and idea has been established by previous doctor or professor or any days with any more professional knowledge. So the second part is the conceptual design. Mainly we develop it is through the flowchart. We draw out the flowchart and write down what we need for the component parts. and the develop encodings. So we build the circuits is through using the Pro Tools software, and the coding is through the Arduino IDE. So the last part is the performance analysis and the result. So we simulate and execute with proper error checking. We check it and test it back so that there is no error in it. So next is the component we use. So mainly we use Arduino Uno board as the motherboard. So LED, a silicon diode, a NOT gate, a resistor, the IR sensor, which show here how it look like. So a motor, a DC motor, an LCD, and an LM35. But this is not the most suitable sensor we should use. Actually, it's more suitable to use MLX 90614. But unfortunately, this is not the library of this component is not produced. So we use LM35 as the alternative. So this how this is the Uno board, the speaker, 5. Both of these is infrared sensor, 2 LCD, the LED light, gate, diode, resistor, and a motor. So next, I pass this to my partner.
Thank you for my group member. So how does it function? So basically, as I said earlier, the temperature screening depends on the crowd controlling system. So in order for the temperature screening system to operate, the number of visitors must be less than the maximum number allowed in the premise. So if the number of visitors is less than the maximum number, the temperature screening will start to operate, and the IR sensor will detect and scan the human temperature, body temperature from forehead, and if the reading is in the range, so it will detect there is no fever from the fever detected from the visitor. So the green LED will lights up, and then the temperature reading will display on the LCD screen, and therefore access is allowed. And then it will connect to the servo and will open the gate, and then that is when the crowd controlling system comes into operation. So the sensor will detect the visitor that comes into the premise, and the number of visitor will plus by 1. And the second situation is when the reading of temperature of the body human is out of range. For example, 57.5. So the sensor will detect that the visitor has a fever, therefore access is denied, and the servo will not open the gate, and the red LED lights up. And the last situation is when the number of visitors is equal or more than the maximum number of visitors allowed in the premise. So the temperature screening will not operate, and therefore no other process will happen. And back to the station one, when the visitor enters the premise and then exit at the exit gate, the IR sensor will detect the visitor that left the premise, and the number of visitors will be subtracted by 1. Next slide. Then this is the video of a circuit simulation.
The sound, right?
No.
Oops. Maybe I repeat again, and actually it's got sound. Never mind, I speak through what I feel. So this is the first condition I say. Press the infrared sensor. when it on, and the temperature. And since here is 36 degrees Celsius, the green LED turn on, the motor turn on, plus 1. So this is the second condition, higher than or lower than the range. Now here we 30 degrees Celsius, 38 degrees Celsius. So the speaker will turn on, the red LED turn on, and the motor is keep closing, means that the door will be not open and not allow he or she to pass through. So this is the third condition, when the number of visitors come to the maximum. So here we put a 3, and the second line will show that this is full and ask the visitor to wait for a while before entering. When there is someone come also, the infrared sensor won't be function. Until someone go out from the locations, so that the system will function as normal. I mean, like before the first or second condition. So we conclusion. So in conclusions, there are 3 improvements that we think we need to do. First is about the temperature sensor. So actually we should change to an infrared thermometer, more efficient and accurate compared to the LM35. So the second is to maintaining the social distance. So we have a idea that we can measure the distance between the people using a camera or a infrared sensor, put it at the entrance, so that before they go in the locations, if it's full already, so even they wait at outside also, they can make sure the distance among themselves is correct. So the temperature, if we put it a camera also, we can get the face of the visitor, so that we can get the data and pass it to the government database, and analysis can determine who and when he go to the place, and we can know his location, his conditions, and make the efficiently. So I think that's it from us. Thank you.
Okay, thank you, Zahimi and Zijuan. Okay, next we proceed to group 9, Korwikan and Sharon, please.
Good afternoon, Dr. Amil. Can you hear me?
Yes.
Okay.
Good afternoon, Doctor. Can you see my slides?
Yes. Please proceed.
Okay. So, very good evening to Dr. Wan Amifort and my fellow friends. So, today, me and my partner Koi Rukang will explain about our project, which is Automated Sanitization System under Mobility and Transportation. So, this is basically the contents in our presentation slide. So, I will go straight away for the overview. So, first is about overview and our project goal, why we are doing this project. So this is because of the COVID-19 pandemic season, government already stopped the use of the public transport. So this affects the daily activity of residents, especially who are going to work. For example, in Kuala Lumpur, people normally will use public transport as their prioritized. So when more people traveling by using public transport, the risk of getting COVID-19 will be also higher, and at the same time, it will also not safe. And sometimes the sanitizer, when it is finished, it will be not refilled by the bus or train operators. Thus, we had came to an idea to overcome this extreme situation by creating this system, which is named automated sanitization system in public transports. So our objectives are to reduce the risk of spreading COVID-19 virus among the passengers, to alert the bus or train operator when the sanitizer level is low or it's about to finish, to increase the awareness of COVID-19 situation to the passengers and also people who use public transport. Then it is about to reduce the use of manpower in order to sanitize the public transport. Moreover, it's also about to save time of the sanitization process. This is because normally people need use of manpower to sanitize the public transport. So this will took up a long time to finish the process of sanitization. So our project will save the time of the sanitization process. And finally, it is about the maintain the cleanliness of the public transport to avoid getting the COVID-19 virus. So next upon, I would like to pass to my partner to explain about the design and the circuit.
Uh, thank you, Sharon Kumar. Now, I would like to explain about our design. Our design consists of two parts. With the first part is the sprayer, and the second part is the sensor system used to alert the operator to replace the sanitizer. Okay, for the first part, the sprayer is modified by the normal sprayer we use in daily life, but is active with a hydraulic press, which can be controlled by electricity. And for second part, the sensor system, if the level of the sanitizer reach a certain height, a black ball will block the LDR from light source and cause it to have a high resistance. We can use this characteristic for the automate alert system. So from the diagram, the part 3, never mind, next slide. Okay, this is the circuit to control the hydraulic press. In the design, our sprayer need to spray at every station when the train stop. So when the train stop, the door will be open. Therefore, two sensors is used. One is the motion sensor of the door, and one is the distance sensor. The distance sensor is to verify whether there are passengers in or out the train. Then the output of these two sensors is connected to an AND gate. The output of AND gate will be high if only the output of the distance sensor and motion sensor are high. After that, the output of AND gate is connected to the base of the bipolar junction transistor. If the output of AND gate is low, which is 0, the output will act as a ground and no current or voltage will go into the base of the BJT, and the BJT will not active. When the output of the AND gate is high, current will pass into the base of BJT and activate the BJT. Then the BJT is act like an automated switch for the hydraulic press. Then for the circuit for automated alarm system, the circuit is built to alert the operator to refill the sanitizer. Two SPDT switches are used to act as a LDR. The circuit at the left is a common circuit, which is same as the circuit for automated street light. When the resistance of LDR is low, by voltage divider, the LDR will have low voltage, causing the voltage into the base of BJT is low and not enough to activate the BJT. Then when the resistance of LDR is high, large voltage will pass into the base of BJT and activate the BJT. Then it will light up the LED for sprayer. Then for the buzzer is connected to a MOSFET, and the output of the MOSFET is gradually decreased after the MOSFET is activated. Then for our discussion and observation, the sprayer will spray the sanitizer when there are passengers in or out the transport, and the LED will light up when the level of sanitizer reach a certain height, and the buzzer will giving alert to the operator of transport for a certain time.
Okay, thank you, Korika. So as a conclusion, we have successfully completed our project regarding to our subject, which is EAM242, and which is titled Automated Sanitization System. So our system was successfully able to spray the sanitizer all over the public transport before the passengers boarding. And also the system was built so that it could produce alarm or buzzing sound and also LED notification when the sanitizer level is low or about to finish. So this would be very helpful for the bus or train operators to alert them to refill the sanitizer. As this COVID-19 pandemic season keeps going, this system will be very helpful in order to reduce the risk of spreading COVID-19. And also, it also allow the people to use the public transport without any worries. And our system also able to increase the awareness of COVID-19 virus between the passengers and also other people. Thus, our project successfully achieved all the objectives stated in the beginning of this mini project. So for the future work, this system will be very helpful for future work also because our automatically spraying sanitizer does not only limited to reduce the risk of COVID-19, and it can also reduce the risk of any other diseases because our target is to maintain the cleanliness of the public transport. So it can be also used for to reduce the risk of other diseases too. Thus, it can in future we want to implement this throughout other public transport and also even in the public places such as mall, stores, and also any other shops too to avoid the spread of diseases and also to maintain the cleanliness of the shop all the time. So for the challenges during the implementation of this code, we also gone through some obstacles such as like wire connection problems, short circuit, and also like simulation problems. But as a team, we managed to overcome all these problems and successfully simulate the system. So we also successfully completed our mini project. So that's all from us. Thank you so much.
Okay, thank you, Ruikan and Sharon. Now, next we invite Group 12, Shi Ying and Lun Ching, please.
Greetings to our lecturer, Dr. Wan Amir, and my fellow friends. Today we are going to present our mini project for the course EEM242 Mechatronics Laboratory 1, which titled as Smart Home Sanitizer. I am Li Shiying and my partner is Onlun Chin. We are from Group 12. Firstly, I'm going to introduce what is Smart Home Sanitizer. A smart home sanitizer comprises a detection system and a sanitizer spraying system. Smart home sanitizer is a system that can be operated by itself through the programming written in the microcontroller to perform some specific tasks. The microcontroller used in this project is Arduino. Arduino is an open source electronics prototyping platform based in flexible, easy to use hardware and software. The objective and the reason we designed this circuit is to support the process of sanitization of the human being at regular intervals, to manage the spread of highly contagious diseases such as coronavirus disease, to sanitize humans with minimum wastage of liquid with maximum effects, to reduce effort, cost, and time, and also to understand and improve ability of writing programming language with Arduino programming.
Good afternoon, Doctor. I'm Ong Lun Ching. So this is the flowchart of our project. In this project, the smart home sanitizer is proposed to be installed at the entrance of a house. The invention will sanitize the person at regular intervals so that the spread of highly contagious virus diseases are reduced to a greater extent. Before the human reach a house, the PIR sensor will detect the presence of the human. Then the door will automatically open. Once the human enters the house, the sanitization process for the whole body of the user will be carried out once the IR sensor detects the presence of a human, and the LED will light up until the human is walking away. The sounder will produce a beep sound once the sanitization process starts. At the same time, the temperature sensor will also activate. When the temperature is too high, the LED will light up and the sounder will produce a beep sound. The signal will also display on the LCD screen. The entire circuit is power and battery operated. The servo motor will start to pump the sanitizer liquid through the pipe. It stops the pump motor by 10 seconds. Next. So here is a short demo video.
Now we are going to show our circuit simulation by using the software of Produce 8 Professional. Firstly, when PIR sensor detect there is the presence of human, the blue LED will light up and the DC motor will rotate to open the door. After the user enter the front door, the IR sensor will detect the presence of human and the green LED will light up. The solder will produce a beep sound and the servo motor will rotate 180 degrees, which indicate the sanitization process. When the sanitization process ends, the beep sound will stop and the servo motor will stop to rotate.
At the same time, the temperature sensor will also activate. Signal will be displayed on the LCD screen. When user's temperature is normal, which is below 38 degrees Celsius, the LCD screen will display temperature is normal. When user's temperature is too high, which is above 38 degrees Celsius, the red LED will light up and the sounder will produce a beep sound to alert the user. Besides, the LCD screen will also display temperature is too high. So here is the appearance of our project. As we can see, the PIR sensor is located right at the front door. After it detects the presence of human, the motor shown in the second picture will be activated to open the door. The last picture shows the IR sensor, temperature sensor, sanitizer, and the LCD screen. While doing this project, we originally planned to use the keypad to let user key in the password before entering the building, but unfortunately, we faced a problem of insufficient pin in Arduino Uno. Then we replaced Arduino Uno to Arduino Mega. But unfortunately, again, the Arduino Mega can't function well during the simulation. So the way we solve is we use a simple DC motor with a PIL sensor to let the door open when PIL sensor detects the presence of human. That's all from me. I'll pass back to my partner. Thank you.
Conclusion. The limitation on this system is that we are using PIR sensor to sense the human. When the ambient temperature is close to the human temperature, the detection and sensitivity will drop significantly, and sometimes even a short-term failure will occur. Another limitation is that whatever is approaching the door, the IR sensors will also give an output. It means that even if pests and animals are approaching the door, the sanitizer system is still on. So for future work, we aim to fix it by replacing the IR sensor to digital image processing. Image processing is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. It is a type of signal processing in which input is an image and output may be image or features associated with the image. By using this technique, we can increase our accuracy against the human recognition. That's all from Group 12. Thank you.
Thank you, Xu Ying and Lun Ching. Now we proceed with Group 5, Chan Chu and Mr. Nabahan. Please.
Hello, my name is Muhammad Nabah Humaidi bin Abdul Hamid. And my partner is Go Chan Chu from Group 5. So today we are going to present our mini project, which is called Digital Counter with Smart Security. So this is the overall what is we want to present in this presentation. For the overview for this project, this digital counter is designed to tackle the COVID-19 because, as we know, in this pandemic COVID-19, we need to avoid the crowded places as we don't want to COVID-19 to be spread. So this digital counter is designed that can maintain a safe social distance in the community. Besides that, this digital counter also provides a smart security system for the user by using an alarm system, which is will be explained more detail in other slide. So next is the methodology. So in this circuit, to accomplish this mini project, we use several logic gate to successfully the circuit. So the logic gate that we use is 74AS04 that function as a NOT gate and acts as an inverter. Logic gate 192 that function as up-down decade counter for increase or decrease the number of people. So logic gate for LS48 for BCD to 7 decoder. Logic gate LS85 that has 4-bit magnitude comparator that acts as a matching mechanism, the one part of this circuit. And 4078 that has 8 input NOR gate that helps in activating the alarm system in guard mode, which is in the security system. And LS08 that has quad 2 input NAND gate that used to switch the alarm system. And LS32 that has quad 2 input OR gate that used to detect the input from the IR sensor. So the benefit for using all of this logic gate is because it has a lower cost compared to the circuit built using Arduino. And the digital counter is also stronger than the Arduino as the microcontroller in Arduino will be damaged easily when there is slightly higher voltage input from the sensor. So for the experimental setup, I will pass to my partner to present it.
Good afternoon, doctor. My name is Go Chan Chu. Can you hear my voice?
Yes.
Okay, I'll continue with the experiment setup. I will present to you the two main function of this project, with the matching mechanism and the alarm system, as they are the most important part in this project. So the first thing I will show is the matching mechanism. Beside here, this is a limit counter where we set it as 10, and now the people counter is slowly increases to 10. When it reaches 10, you can see that the LED is light up, means the full signboard will be light up to stop people from entering the place. Will be lighted up as soon as the LED is light up. So when the people leave the area, let's say 2 people leave the area, so 1 and 2, now become 8. The LED will be dimmed down and the full signboard will be dim. Yes, as you can see here, the LED is dimmed down. So from the matching mechanism conclusion, the result is that when the limit counter and the people counter match, the full signboard will be turned on. When the limit counter and the people counter does not match, the full signboard will be turned off. Next, I will present to you the
the alarm system. How the alarm system will work? The entrance or the exit alarm system will. The alarm system will alarm mode. As you can hear, there's a sound coming from the buzzer. In order to stop the buzzer, all you need to do is reset the SR latch by pressing the space key. Yeah, the sound is off. So that's all for me. The entrance or the exit. So from the conclusion of the alarm system, when the red line is the input from the IR sensor, input to the SR latch, and the blue is the output SR latch. As you can see here, that's only the input is only a short amount of time, which activate the SR latch. The output from goes from high to low at this level when the SR latch is reset. So let's move on to another slide. So conclusion. The digital circuit works properly as we design the system to count the people, match the people, and also the system. Next, the curve of COVID-19 can be flattened from social distancing. Yeah, we set the limit, and then the people counter will stop people once the people counter match the limit. And of course, the cost is lower as it only use digital logic IC gates compared to using Arduino Uno, which is much more expensive. Next, future work. So there are times when there are people entering and exit at the same time. So the combination of this XOR gate and the AND gate can cancel the error cost because as the XOR gate, when two input is high at the same time, the output will be low. Next, the future work we like to implement is the 555 timer to work as a bistable state. So the 555 timer can work in a very stable bistable mode, which can be triggered and resetted, as seen as this S1 and S2. So the active high SR latch may give an unstable output if and are short and connected to the high input. So the SR latch is not stable when both of the input are high, and it will give an not stable output. So next, the 555 timer is also widely available in the market, so you can purchase it easily. I think that's all from us, from Group 5, and thank you. We also uploaded the video documentation in the YouTube link. And that's all from us. Thank you.
Okay, thank you Chanchu and Nabhan. Betul lah? You are group?
Yeah.
Yes,
First.
Nabhan.
Okay. Okay, next group 1, please. Nur Hakim Abdul Ghaffar. Okay, please.
For smart tourism purpose. We are coming from group 1. Our member is Ahmad Nur Hakim and Abdul Qadir Ghaffar.
Your voice is too slow.
Hello, testing. Can you hear me now? Is it
Boleh kuatkan lagi tak?
Yep.
Please increase your microphone sensitivity.
Okay, let me check first. Hello, testing 1 2 1 2.
Can we go to group 14 first, then we come back to group 1 later on? Group 14, Kem Yang and Zeng Kao. Boleh, can we invite group 14 to go first? Okay. Okay, group 14, okay. Please.
Hello, doctor. Can you hear me?
Yes, please.
Yeah. Good afternoon, doctor. We are from Group 14, and the title of our project is Smart Delivery Car. The COVID-19 pandemic outbreak has caused a lot of problems to the society globally. One of it is the problem towards the transportation system. Instead of the transportation of the community, we had the idea of designing a smart delivery system for the smart delivery car, which can deliver goods and items to people without delivery man. The objective of our project is to prevent the crowding in the market and store. Since human can obtain the daily needs throughout the system we design easily and more safely. This can help to avoid the spreading of coronavirus since the social distancing can be practiced. Besides that, the objective is also to prevent the interaction between the delivery man and customer to protect them in case that one of them may having the symptoms of the disease. The circuit we designed contains of two parts, which is a weight sensor circuit and a timer and scanner circuit. We designed this through the process of the idea we plan, which is first, the smart delivery car will store the goods and parcel inside the car from the seller. The number of stock in the car will be determined by the weight sensor circuit. Then the car will move to the customer place to deliver the item and return to the seller place once all the items had been delivered to receive another batch of order and deliver it again and again. When the car at the customer place, the process of customer taking the respective item inside the car will be handled by the timer and scanner circuit. So we design a circuit through this process, and the simulation of the circuit will be shown by my teammate Keng Yang.
Thank you, Chen Xiao, and good afternoon, Doctor. My name is Lin Keng Yang, and I will present about our circuit. So as Chen Xiao said, our circuit consists of two parts, that is weight sensor system and QR scanner system. So as you can see, there is 6 switches on the left, and each switches represent the weight sensor. Means when a parcel is stored in the slot, then the weight sensor will be triggered and become closed circuit. For the 7-segment display on the right, will show the number of the parcel that is stored in the car. For the QR sensor, the code scan will be converted into the 3-bit signal represented by switch. And then the respective actuator will be activated and move the parcel to the dispenser. And because our circuit is quite bulky, so we use a lot of sub-circuit to save the space. Next. Okay, display the video, thank you. So this is the weight sensor system part. So as you can see, the 7-segment display will display the number of the weight sensor that is triggered, regardless of the order. And our maximum storage is 6 currently. Okay, next. Okay, this is the QR scanner part. So let's say when the signal is 001, then the first LED will be light up. Oh. I think I present my part is better. Sorry, I can stop share. I think I present this part. Sorry for the waiting. So this is some sub-circuit I said before. Because the circuit is too bulky, so we have to save space. For this, this is the full adder, half adder, and the timer circuit. As you can see, this timer is a page already. So continue to the result. So when the signal is 001, the first LED will be activated means the actuator will move the first slot of the parcel to the dispenser. And then the actuator will activate according to the signal. So any LED lighten up means the actuator is activated. But as you can see right now, every LED is closed. Oops, sorry. Okay. Also, as you can see here, even though the signal is 100, which means the fifth LED should be lightened up, but the LED is closed because we use a timer so that, let's say when the customer has missed their parcel and they cannot get their parcel themselves, then after the time limit, that is 60 seconds, we will shut down every actuators and let the robotic car to move onward to the next customer. So we will not wait forever for them. So after the time limit has passed, we will shut down every actuators regardless of the signal of the QR scanner. So this is basically our circuit. So while we are doing this circuit, we face a lot of problems. And the biggest problem is that the Multisim has only limited space to construct the circuit. Because as you can see, the timer is already all page. So we solve it by using the sub-circuit feature we discovered ourselves. It saves quite a lot of space actually. And then second problem is the Multisim can only place up to 50 components only. Luckily, USM has provided us the license to the educational version so that we can actually place, I think it is 200 or something, about 200 more components. It is we can create more bulky circuit. So in conclusion, we created a conceptual circuit that will be implementing in our smart delivery car design. We also learned mostly about the digital electronic, like the logic gates and the ICs throughout the process. And also getting a lot familiar with the Multisim software. For the future, we are really hoping to make progress on the prototype because this is just the simulation part. We don't get the chance to actually making the structure part, like the past year project. So we really hope we can design and build the actuators, especially the motors that can actually move the parcel to the dispenser part. That's all for Group 14 presentation. Thank you. And sorry for the trouble.
Okay, thank you, Kenya and Zheng Kiao. Now can we... are you finished? You finished? No. Finish.
Yeah, finished.
Okay. Thank you, Group 14, Kenya and Zheng Kiao. Now can we proceed? We continue with Group 1, Abdul Kadir and Ahmad Nur Hakim. Please. Who is speaking? I can't hear you. We can't hear you. Or is it my speaker? It's not working.
It's not working. Actually, excuse me, doctor. Actually,
Later.
Ahmed Nur Hakim, he speak. He forget to turn on his speaker.
Okay. Ahmad Nur Hakim, can you hear me? We are we cannot hear you. You probably muted your microphone. Or even your speaker is not working. Nur Hakim, we still cannot hear you. Okay, can group 20 override first? Group 20, can you come forward first? And please start your presentation later on. Okay. Thank you. So now we are having group 20. Okay, please.
Okay, yes. So good afternoon, doctor. So our presentation, I'm Tan Jiawei and Tan Hoyan. So our presentation topic might be about the smart air purifier system. Next. The slide. Yes. So come from group 20. So for the introduction part. So for introduction parts for based on the definition of smart air purifier. So it's an application which operates through programming codes in microcontroller to implement variety actions of purifying air surroundings. So and then the smart air purifier system also design circuits by using Arduino. So it was an open source electronics prototyping platform based on flexibility, easy to use hardware and software. And then by using SolidWorks, its prototype is designed where the application designs all mechanisms of air purifier in terms of its length, size, and shapes. Next slide. So for this project, there are several objectives, which was design and fabricate smart air purifier, which purifies air surrounding automatically, and especially during this COVID pandemic, for this smart air purifier system is so useful to control the quality of the air. And then next, to determine the most suitable mechanism of motor fan to absorb the air into the air purifier tube. And then understand working concept such as conservation of electrical energy into mechanical energy of the fan motor. And then understand improved ability of writing programming language for the Arduino programmer, so to improve the system, the functions, implementation function of the smart air purifier, and then design electrical circuit required for the smart air purifier. And then lastly, understand and optimize the functions of each sensor. Next. So based on this methodology, it describes about the SolidWorks prototype of smart air purifier is done by using SolidWorks. There are 5 parts, which was steel box cover, steel tube, motorized fan, and filter net. So in the diagram also the prototypes of the smart air purifier, its partial components. So next. So there are several prototypes, and then for the next one, they are shown in terms of the side view, top view, rear view, and then their dimensions, respective dimensions. Okay. So the last one is shows the overall product, as product build form. When all are combined, they forms the prototype. So next. So the presentation pass to Hui Han.
Okay, good morning, doctor. So this is our Arduino Proteus design for the smart air purifier circuit. Okay, so as shown, this is the center one is our Arduino Uno, which is the motherboard for the main circuit, and at the right hand side is our motorizers DC fans. And the second component is our temperature and humidity sensor. So for the motorizers, DC fan is for the air purifier to move and absorb the air outside, and the temperature and humidity is to detect the temperature and humidity surroundings, and it will send the data to LCD and also our phone or computer by using the Bluetooth. So the third component is our dust sensor. The dust sensor is a PPD42 which can detect the size of particle small until 0.3 micrometer, and this will sense the dust particle size around the surroundings and detect the concentrations. If the concentration is lower than 600 piece per CIF, it will send the data to our Bluetooth, and hence the smart air purifier will start to operate. The third one is our LED. So for the LED, it is to indicator for the air purifier circuits when the concentration is more than 600. So it means that the smart air purifier will start to function, and hence the LED will light up and tell us that the smart air purifier is operating. And the last component is our Bluetooth module. The first Bluetooth is to represent the Bluetooth in our circuit, and the second Bluetooth is to represent the Bluetooth on our phones or computer. So we can like data from the circuits by using Bluetooth. And this is our LCD, and the potentiometer is to adjust the light of the LCD. So you can get it bigger or smaller to adjust the light. Okay. So the next one is a working principle. So as can see, the first is the Bluetooth module. As just now I say, the Bluetooth module, the first one is to represent our main circuit, and the second one is to represent the screen of our computer. And the second function is that when we press 1 in our phone or computer, then the smart air purifier will start to move or start to operate. And when we press off in our or we press 0 in our phone or computer, then the air purifier will stop to operate. So like this, it can easier for us to switch on or switch off. Then in order to receive the data in the virtual terminal or our phone screen, so we need to install a phone apps, something like the Blinks is a apps like the codings app to receive the data, or the Arduino app from the official website. So the last one is that the temperature and humidity values will show in the LCD and let us know that the temperature and humidity surroundings, and also can show that the air purifier is on or off and the air quality surrounding. Okay, so next is our result. So as can see, when power is on, it will just turn on the back with light of the LCD screen. So when we press other than 1 or 0, so it will show the error 404. It means that it will not working. So when we press 1, it will show that the smart air purifier start to running, and when the concentration is lower than 600 piece per 0.01 CF, or in milliliter, is CF is equal to 283 milliliter. So can just convert, but in here we using the unit of piece per 0.01 CF. So as you can see, the air quality is so good and air purifier is off. Okay, so the next one is when 600. So the air purifier will start to function, and the LED light ups, everything is going on. Okay, so the next. So this is the conclusion for our smart air purifier. So the design and fabricated with the aids of SolidWorks for the prototypes, and we're using the Arduino codings for our internal circuit implementation. And the components we use here is a steel box cover, steel tube, and motorizers fan. So the mechanism of motor fans is that the electronic circuit is controlled by the sensor in the input circuits, and the working for the main circuits is that it converts the electrical energy to mechanical energy. So we're using Arduino program for this circuit, in the future works, maybe we can replace the motorizer DC fans with a bigger and more powerful one so that it can absorb more air surroundings outside and also improve the capacity for air filter. Okay, so thank you. Thank you, Doctor.
Okay, thank you, Group 20, Chow and Hu Hang.
Okay.
Next, can we have Group 1?
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1.
Wassalamualaikum.
We are presenting smart sanitizer dispenser for smart tourism purpose. Today, I'm Hakim and my partner Abdul Kadir Dafa will present about this one. We are presenting starting from the introduction and objective up until the future works. We get the topic to design a system that can combat the spread of COVID-19 pandemic. The crowded place such as tourist attraction poses the risk of spread via surface contact, and the capability to sanitize hand without the need of touching, for example contactless, is compulsory. This is for minimizing the frequency of contact with surrounding, especially when you are in a crowded place or a tourist attraction. For our objective, we are needed to design a smart tourist system that prevent the spread of COVID-19 and to allow user to use sanitizer without the need to touch through contactless triggered sanitizer dispenser. Our methodology, we are using IR proximity sensor to detect the presence of hand under the sanitizer, which will dispense the sanitizer by pumping the sanitizer directly into the hands of user. Plus, when the sanitizer is empty, the ultrasonic sensor will detect the level of sanitizer left inside the reservoir to alert the user that it is empty. Those systems will be powered using DC supply voltage 9 volt and will be put in a strategic place for everyone to use. For our methodology, this is our flowchart system in our prototype. We have. Okay, Abdul Kadir, can you proceed?
Okay, thank you, Hakim. Now I will describe the design architecture of our project. We can see from here there is a bomb, an IR proximity sensor, LED, and the bottle and the others component that we use in our project. We use the bottle to keep the sanitizer in the bottle, and the bomb will be inside the bottle to pump the sanitizer to the hand person, while the IR proximity sensor will be the input for the system. It will be to detect the hand person. So what about the distance sensor and Arduino Uno and buzzer? Those, it will be alarm when the device does not have a sanitizer. Means that the sanitizer it finished. So the distance sensor will measure the distance from down the bottle. Then it will be on. After that, the buzzer will turn on to alert the security room to come and refill the sanitizer, the device. Next. So the software tools that we use is Arduino software, Multisim, and SolidWorks. For the Arduino software, is used to control the distance sensor, red LED, and buzzer only. Next. Here is the connection of our circuit. We can see the IR proximity sensor, MOSFET B channel, and bomb, which is represented by red LED, is connected together to do the function of automatic sanitizer dispenser, while the buzzer and distance sensor were connected to the Arduino to do the alert when there is no sanitizer in the bottle, in the device. Next, please. So it is clear from the connection there are two cases in our project. When there is a sanitizer in the device, it will be the flow chart like this. The IR sensor will detect the present hand. Then the pump will flow through the nozzle to the present hand that detected by the IR proximity sensor. Next, please. While the second case, when the device doesn't have a sanitizer, the distance sensor will detect the distance, which is the end of the bottom of the device. Then the red LED will turn on. In the same time, the buzzer will alert. Next slide, please. Here, this circuit was built using the component that I mentioned. So, can you please turn it on? Yeah, we can see from here. This is the function of the device when the bottle has a sanitizer. So, see, this is the hand. The sensor detected the hand. And finally, mashallah, you can sanitize your hand from coronavirus. Next slide, please. Next. And this is another function when the bottle does not have a sanitizer finish. When the sanitizer is finished, so directly the buzzer will alert. Oh, I cannot hear sound.
The volume is already at the maximum.
Yes.
Next slide, right?
Yeah. Okay, now the next slide will be presented by Ahmed Nur Hakim.
Okay, from our simulation prototype, here are the Multisim representation for circuit schematic. Basically, we have IR proximity sensor and a distance sensor, which have two, and now we already have two output to represent the pump to the sanitizer and the pump that pump the sanitizer towards the nozzle. The result of simulation, we have a red LED, green LED, and a pump. For IR proximity sensor system, when the hand is presented under the nozzle, the red light will be inactive, while both green LED and the pump will be active, indicating that the prototype will pump the sanitizer for user to use. In contrast will happen when the hand is not there. Where the red LEDs is active, the green LED and pump will be inactive, indicating that it will not function until the hand is presented back. For alarm label indicator, when the sanitizer presented above the minimum level, the buzzer will not be active. In contrast will happen when the sanitizer below the minimum level, where the ultrasonic sensor will detect the level of sanitizer and send a signal to the buzzer for it to buzzing. And simulation and prototype testing produce the same output. In conclusion, this device can be utilized to combat the spread of COVID-19 by utilizing the contactless sanitation method. Thus, the objective of our prototype has been achieved. For our future work, since we use DC supply, for example 9-volt battery, we can add a bridge rectifier for AC alternative compatibility option. This is to reduce the reliance of battery and allow user to have a variety choice for powering the device. Plus, This concept can be repurposed into sanitizing luggage bag for airport or bus station, etc. That's all from me and from us. Thank you and have a great day.
Thank you, Group 1, Abdul Kadir and Ahmad Nur Hakim. Now, can we proceed to Group 15, Zhao Hong and Ming Zun, please?
Good afternoon, Doctor. I'm Loy Mingxun from Group 15, and we will use a video to give a clearer grasp of our project on contactless tracker and cloud limiting system.
Hi everyone, I'm Lin Zhao Hong from Group 15, and our topic is Smart Security. We name our project as Contactless Tracker and Crowd Limiting System. The surge of COVID-19 pandemic has affected the world's daily life for more than 1 year. Until now, we are still affected by this pandemic. In this case, we are trying to strengthen the MySejahtera tracking system to avoid the spread of coronavirus. We found an issue that some of the people do not have a MySejahtera account, thus they have to write the personal information on public, and this will cause the personal information exposed to other people. Also, some of the people do not fill in their information. Hence, this will make trouble in tracking infected people. Besides that, from the point of shopping mall, they are hard to limit the number of people in the mall. Thus, the space might not be enough to maintain social distancing. In order to solve this problem, our proposed solution is using our contactless tracker and crowd limiting system.
In order to achieve contactless data transfer, we introduced the usage of RFID, which is already widely used in the bank card. This technology required RFID tag or card, RFID reader, and a device to analyze the signal received. There are various types of wristband which is portable to carry and not easy to lose comparing to the tag or the card. We suggest to make the RFID tracker with a durable and waterproof material to one of these shapes. In order to limit the number of people entering the shopping mall, we can limit the number of trackers like up to 300 pieces. The visitors are required to wear the tracker all the time and before entering the mall. Once they detach it and leave, the tracker is sanitized and ready to be used by the next user. Now, I will demonstrate the data transfer process using Proteus simulation. Unfortunately, we do not have any RFID reader module with us, and we are not able to find a virtual one to simulate. So, we replace the RFID input with a numerical input of a keypad. Firstly, the name and IC number of the user is stored in the device according to each tracker number. For example, tracker number 1 is held by Aaron, tracker number 2 is held by Benson. When an input is detected, the name, IC number of the holder will be recorded in an Excel sheet. This enables the host of the system to track the date, time, and also the identity of the visitor.
We plan to use this circuit in a shop at the mall. When the RFID tag or card are successfully transferred data to reader, the door servo will open, then the counter will +1. The customer are allowed to enter. When the customer are going to exit the shop, he or she will also need to use the RFID tag or card to open the exit door servo. Then the counter will -1. This LCD we are using to show the number of the customer inside the shop. We will set a limit to limit the number of customers. In this case, we set the limit as 3. When the limit is reached, the open door servo will not open again and to limit the number of customers inside the shop. And the 7 display will show a full to let the customer know the customer inside are reached the limit.
We plan to output our data to another platform other than a serial monitor, which is difficult to record. With the tool software shown, we're able to output our data to Microsoft Excel, which is tidy and easier to handle.
For future work, we will try to use other sensor or device to let the RFID tracker make noise when the device are keeping less than 1 meter distance. This can make sure that the customer keeps social distancing between each other in the shop.
We can also implement IoT, which is Internet of Things, to allow the admin to manage and do the administration work through Internet.
That's all from us. Stay safe and thank you.
Okay, thank you, group 15. Now can we have group 10, Jishan and Siltran,
Yes, doctor.
please?
Yes, doctor. Can you hear me, doctor?
Yes, please proceed.
So, good evening, doctor. We are from Group 10, and is Sridharan, and my partner Jishan. So, based on the theme given, which is smart tourism, we came up with a project that is called Virtual Club System. So, these are the contents that we included in our presentation. So, a basic overview. So, virtual queue system allows guests to save time for traveling party because they will reserve time before visiting a place. So, why we came up with this project is to allow a place with greater emphasis on social distancing and to control the number of guests who are in the queues at most popular attractions. So, the main objectives that we wish to achieve in this project are to avoid crowds at the tourist attraction spots, able to trace the source of the COVID-19, avoid time consuming for long queue, which will give them more time to explore other tourist places, and also to prevent frequent close contact between tourists and tourist guides. Next, so a brief introduction. So ever since COVID-19 has been declared a pandemic by World Health Organization, government of all countries have been taking strict measures to overcome this by limiting people entering a place and also implementing the must of wearing masks to prevent further spreading of the disease. And in our country, since tourist attraction is a major contributor to our economical things, this reduction of tourists entering our country dangers our country economically. So we came up with a project to limit and control the number of tourists visiting a certain tourist spot, particularly a most popular one with more crowds, which we name it as a virtual queue-up system. So basically, this is our project. So for the experimental setup, these are the components that we used in our circuit, LEDs, which acts as indicators and other things. So next, I would like to pass this to my partner, Lijishan. Thank you.
Good afternoon, doctor. Can you hear me? So this is the circuit schematic of our project. Please allow me to show the demonstration of the circuit. Doctor, can you see the screen?
Yes.
Okay. So imagine you are the visitor. So you need, when you approach to the tourist site, you need to detect the temperature. So what if the temperature is above than 37.5, which means that it is high? So here we'll give the output of 1 and the QR sense scanner, which means that the visitor need to scan the QR code just like what we did for the My Sejahtera apps. So if the visitor temperature is high, the alarm will stop in and not allow the visitor to enter, which we show here is 0. So if the temperature is low, which means that they will allow to enter the tourist site until it reach maximum number. As you can see here, the audio guide system will be turned on when the first person enter the tourist site. So when you will see here, when it reach maximum number, which is we make it as 9, the maximum people will be shown and a time notification will be sent to the visitor from the time reservation system to allow them to make a reservation time. So when people are leaving from the tourist site, so you can see the number will be decreasing and the audio guide system will be automatically turned off when there is no people enter. As you can, this is to reduce the use of an electricity. So, as you can see from the circuit just now, when the body temperature is more than 37.5 degrees Celsius, the alarms will ring and deny the access of the visitor. Meanwhile, when the body temperature is below than 37.5 degrees Celsius, the visitors are allowed to visit the place and to avoid the spread of COVID-19 disease. So when the number of visitors reach maximum, the next visitors will not allowed to enter anymore, and a notification is sent from the time reservation system to the visitor to make their reservation time to avoid crowd. And also, the audio guide system is automatically turned on when the visitor enters to the tourist attraction to reduce the chance of close contact between tourist guide and the visitors. And of course, when there's no people in the visitation place, the audio guide system will automatically turns off to conserve the usage of an electricity. So for the future of our project we hope that we can add a device that used to detect the distance between each tourist inside the tourist attraction. So another thing is that we hope that we can add a device that automatic disinfection around the tourist attraction. So in conclusion, the system that we constructed can determine the source of the outbreak of the COVID-19, and it can also control the maximum number of visitors in the site and encouraging social distancing. Furthermore, visitors can save time without waiting for a long queue by just using the booking time from the time reservation system. And also, the close contact between the tourist guide and tourists can be avoided. So that's all from our group. Thank you, Doctor.
Okay, thank you, Jishan and Citron. Now we only have 10 minutes remaining. So that's completed for today. Anyone from group tomorrow wants to present? Only one group can go. Group 8. Okay, please, group 8. You may proceed.
Nazim, are you here, Nazim?
Hello. Salam, Doctor. Assalamualaikum.
Salam. Waalaikumsalam warahmatullah. Okay,
So,
can proceed.
can you see my screen, Doctor?
Yes.
Okay.
Okay.
So we have came up with a smart home security system comprising a set of devices. The objectives are to design a smart home security system that able to ensure the safety of the user throughout the pandemic COVID-19, and to design a smart home security system that able to open the door automatically to allow the authorized person to enter and close the door for unauthorized person. So this is not invention, but we can definitely say this is an innovation because product like this is already in the market. But what we have done to it is we have created a system that has both security and health screening system together so that it satisfies the requirement of this project. So this is the schematic of our smart door lock. As you can see, we have sanitizer, fingerprint sensor, counter, and of course Arduino to control all the other elements. So our door lock will look something like this with fingerprint sensor and latches. So next, this is our smart alerting system, or we can say this is an alarm. As we can see, we have some motion sensor and vibration sensor. So the motion sensor will look like this, which will be placed in common area in the house, like living room. So let's say the residents of the particular house are on vacation, like for 3 or 4 days. All they have to do is press the trigger or the button, which will activate the system for that period of time. So if let's say during that time, if the motion detector detects any motion in the house, it will trigger the alarm. So by this way, we can secure our house. Same goes to the vibration sensor. It will look something like this, which will be placed in all doors and windows in the house. So whenever there is vibration detected in windows and doors, it will trigger the alarm. So the thief will escape from the house. So this is the synchronous up counter. And this is the schematic for display health. And finally, this is an schematic for amplifier, which will be implemented in alarm, which will amplify 5 volts into 10 volts. So I would like to pass to my partner to continue.
Okay, yeah, thank you, Nazim. Good evening, sir. So I just going to show the simulation for this smart door lock. So at first, if someone press the fingerprint sensor, okay, then the counter start to run. Then the clock has an input high so that the counter is able to run. Then after that, the sanitizer, there will be a short sanitize session. Okay, then only the door will open. So we can see that the buzzer, it rings 5 seconds before the door close. It's actually to notify the user that the door is going to close. So and after that, that when the door close, then the latch also will close. So for the next will be I will call it manual. Okay, so for the next, I will call it manual operation. So what if like one day the fingerprint sensor doesn't work? So there's another way, like maybe the user have another spare key or somehow. So I'll put this here, the alternative key sensor here, key LED here. Okay, so so after we turn on this, we can use this potential meter, which I use it as the manual control for the motor. As we can see, latch can control the latch motor, and the door can use to control the door motor. Okay, so just now Nazim has already gone through it. Okay, so actually it's the sensor high, then clock high, counter start, then sanitize session, then the motor will run, then the buzzer ring 5 seconds before the door close. After the counter end, the door will close. So the total process takes about 15 seconds. So the 15 seconds will be put on the counter. Then if the sensor sense nothing, input low, then there will be nothing happens. Then for the manual operation, as we can see just now, okay, so just the alternative high, the door can be manually controlled. Then for the alert system, Nadim has also gone through it just now. So any of the LED, any of the sensor got any input, it will triggers the LED the alert light and also the alarm system. So in conclusion, this smart home security system has been successfully designed. And to complete this project, we have also applied the knowledge of digital and analog to complete this project. So the automated door lock is designed and can also be operated manually. Then the smart alert system has been designed and the door actuating mechanism has been determined. And this system is also able to lower the criminal rate and the risk of infection with COVID-19. So the problem faced will be using this software, such as the Arduino and the Proteus. So since we are just communicating to this, so there might be some problem, like internet problem. So for the future work, I would recommend can implement the face recognition technique to replace the fingerprint sensor to promote more contactless, and also to apply electromagnetic system for the door actuating system. So that's all from our group. We are group 8. Okay, thank you.
Okay, thank you, Rong Kwan and Nazim. I think that's all for today's presentation. Then before you go, I would like to stress again the submission, what need to be submitted. Okay, for your, as mentioned previously, during the first or the second weeks, for the mini project, you will be assessed on 3 assessment method, which is the presentation and the demo just now, the video documentation, and also the final written report. Final typing or written. So your video documentation, which you need to upload to the YouTube and use this naming convention. Okay, USM 2020 hashtag EEM242, group number and your title. Okay, later on, once you finish, then you zip it, or in each folder, if you have the proposal progress, then you zip it together in each folder. So the folder will be the name of the main folder will be your group number, and then inside that you'll be having this folder which is proposal, progress, final, presentation slides, video, photo sequence, and also the photo themes. So as mentioned previously, these two is optional. If you have it, then you can keep it together lah. And then all of this for the video is please do not archive or zip your videos. You just in the video folder, inside that you name it as the text file EM242 group number, and then the video URL. This is a name. Okay, inside that you write your YouTube video URL on that. Okay, so this from the final presentation video and the photo sequence and photo themes, all of these you compress using the zip ataupun or RAW archiving software lah, and then you name it to EM242 group number is either zip or RAW. Okay, later on the submission, even though is stated here is 20th January, it is on Friday. We extend it on a Friday. Here, Friday 22nd January, submission one of the RAW report through the e-learning site. Okay, later on, starting from tomorrow or the day after, I will open the link for the submission. Okay, I think. Okay, I think that's it for today. Any question? I don't know. We are 4 o'clock. So tomorrow at 2 o'clock, please come early lah. Then we start at 2. Okay?
Sorry, doctor. Can I ask something?
Yes.
Yeah, about the video URL, right? Do we need
Yes.
to where do we need to include it? Is it include inside the report, or we make another Word file to put the URL inside and name it as the video URL?
Both.
We need to include in the report also, and also another Word file to. Okay.
Another text file. Use text file TXT.
Okay. So about the video documentation, is it just like the demo with the explanation?
How to say it? Is the documentation? It's up to your creativity. Okay, it's open to your creativity. If you want to get the idea, you just go to YouTube and you type the search EEM242 or EEM355.
Okay, doctor.
Okay. Anything else? Tak ada. Then see you tomorrow. Thank you for your attendance and for your attention. Okay. Assalamualaikum warahmatullahi.